Okay, let's find the surface area of a torus today. And let me show you what's going on with this torus, hopefully. Okay, here we go. Here's the XY coordinate system. Here's X, here's Y. We're going to have a circle here. Center of the circle is at big R, comma 0. The radius of the circle is little r. And that circle is going to be revolved around the y-axis to form the torus. And we want to find the surface area of the torus. Okay, well, let's call the surface area A. Okay, and we know the area, we'll find it by integrating over the circle. So I'll just say I'm integrating over the circle C. And if we look at a typical point on this circle, this point XY here, then this distance here is X. Okay, and then you've got a little piece of arc length here, which is ds. Call that ds. Okay, and then the surface area of the torus is the integral over the circle dA, where dA is the typical piece of surface area that's generated by this typical piece of the circle of arc length ds. Okay, so the dA is equal to this arc length here, this little ds here, multiplied by the distance that it travels as the circle gets revolved around the y-axis. And that distance that it travels is the circumference of the path of this point xy right here, and that circumference is 2 pi x. Okay, so we get the integral over the curve, the circle C, 2 pi x times ds. Okay, but ds, well, let's not address ds quite yet. Let's go ahead and use our parametric equations. Let's go ahead and get parametric equations for the circle. Okay, so here's say we have the circle here. And the equation for x will be x equals our big R plus little r times the cosine of t, and y will be equal to little r times the sine of t. And of course we'll go one time around the circle as t goes from 0 to 2 pi. So 0 is less than or equal to t, t is less than or equal to 2 pi. Okay, so we just need to go into our integral here. The integral is going to be a t integral, and the limits of integration are going to be 0 to pi. We'll be able to pull this 2 pi out. We'll replace x by r, big R plus little r cosine t. And let's go ahead and figure out what ds is. And ds is equal to the square root of dx squared plus dy squared but that is equal to the square root of dx dt squared plus dy dt squared times dt. I need a square here. Let me put some parentheses in over here too. Okay, but dx dt, come up here and look at x. Both the r's are constants. So dx dt is negative r sine t, and when that gets squared, we get r squared sine squared t. So we have r squared sine squared t. Okay, and then plus, and dy dt is r cosine t, so we square that, and we get r squared cosine squared t. It's a 2 here. It's a 2 there, of course. Okay, now if you look under the under the radical there, you can, and we have our dt on the outside here too. I forgot about it, so put that in here, dt. Okay, if you look under the radical, you can factor out the r squared under the radical, and you get r squared times sine squared t plus cosine squared t, but sine squared t plus cosine squared t is 1, so for our ds, we get square root of r squared times dt, which is r dt. Okay, so ds is just equal to r times dt. Okay, so we're ready to go now with our integral that's going to give us our area. We get a is the integral as t goes from 0 to 2 pi. Okay, and then we have 2 pi times our x. But x is big R plus little r cosine t. And then times our ds, but ds is r dt. So we have r dt here. Okay, and we can factor out a 2 pi little r out of this. We get 2 pi little r times the integral from 0 to 2 pi of, let's see, big R plus r cosine t, that's little r cosine t, dt. But when you look at this integral, you're going to split it up into 2 integrals, and so you'll have integral from 0 to 2 pi big R dt plus integral from 0 to 2 pi little r cosine t dt. But if you look at the graph of the cosine function from 0 to 2 pi, you've got the same amount of area above the t-axis as you have below the t-axis, so all the area cancels out. And the integral from 0 to 2 pi cosine t is 0. Okay, so for our area, we just get 2 pi times our little r times integral from 0 to 2 pi big R dt. Because this integral of cosine t that we get from here, since we're going from 0 to 2 pi, ends up being 0. Okay, so we have 2 pi times little r times the integral from 0 to 2 pi big R dt, but the integral from 0 to 2 pi big R dt is 2 pi times big R. Okay, so for our surface area, we get 2 pi times little r plus 2 pi times big R. Or, sorry, times. We get 2 pi r times 2 pi times big R. And we do that, take that product, and we get 4 pi squared times little r times big R. And that's our surface area. Thanks for watching.